Hello everyone. So in last lecture we discussed about main effects, interaction, first order interaction effect and second order interaction effect in 2q factorial experiment. And after that we discuss about statistical analysis of 2q factorial experiment when we arrange this experiment in randomized block design. So today we are going to discuss statistical analysis of 2q factorial experiment. In this, we will discuss hypothesis testing, then formulas for sum of squares, and after that we will discuss about ANOVA table. So let us discuss about these topics. So here we have these different hypotheses for main effects, interaction effect and block effect. So here our first hypothesis is H01 and it is there is no significant difference between block effects versus H11. At least two block effects are differ significantly. So here we first discuss which block effects are differ significantly, or is there is any difference between block effect or not. Then second hypothesis is for H0A and it is main effect A is not significant versus H1A main effect A is significant. So in this hypothesis we will discuss that main effect A has any significant effect on their levels or not. Then third hypothesis is for block effect. Third hypothesis is for main effect B. So it is H0B, main effect B is not significant versus main effect B is significant. So for this we will discuss how main effect or there is a significant effect of factor B with their two levels. Then next is H0 AB, interaction effect AB is not significant versus H1 AB, interaction effect AB is significant. Then H0 C, main effect C is not significant versus H1 C, main effect C is significant. Then next hypothesis is H0 AC, that is interaction effect AC is not significant versus H1 AC, interaction effect AC is significant. Seventh hypothesis is H0 BC and it is interaction effect BC is not significant versus H1 BC, interaction effect BC is significant. Then last hypothesis is for second order interaction effect and it is H0 ABC, interaction effect ABC is not significant versus H1 ABC, interaction effect ABC is significant. So these are the different hypotheses for main effect, first order interaction effect and second order interaction effect ABC. So in last lecture we discussed about this treatment totals. So when we consider square bracket or when we consider any treatment combination in square bracket, it denotes treatment total. And open bracket denotes treatment means. So in 2q factorial experiment we have 8 treatment totals or 8 treatment combinations. For that we have treatment totals and it is square bracket 1, it is A, B, AB, C, AC, BC and ABC. So for this here we will discuss factorial effect totals. So for factor A, factorial effect total is denoted by square bracket capital AB and it is ABC square bracket, that is treatment total for ABC plus the square bracket A, AB, AC minus B, minus C, minus BC and minus 1. So we know that main effect for factor A, main effect for factor B and main effect for factor C, and we have derivations for this. So with the help of that derivations we can remember these factorial effect totals. So we know that what is main effect for factor A, it is 1 by 4 A minus 1 into B plus 1 into C plus 1. Then simplify this bracket, A minus 1 into B plus 1 into C plus 1. So after solving these brackets we get terms in treatment means. So only replace that treatment means by treatment totals. So we get this formula ABC plus AB, sorry, plus A, that is treatment total for A, or treatment A total, then AB treatment total, AC treatment total, B treatment total, C, BC and 1. Then similarly, to find this factorial effect total for factor B, or to remember formula for this, first remember formula for main effect B. That is, so formula for main effect B is 1 upon 4 A plus 1 B minus 1 into C plus 1. Just simplify that brackets. So whatever the value or whatever the terms we get after solving bracket A plus 1 B minus 1 into C plus 1, replace that treatment means by their treatment total. So we get this formula ABC plus B minus 1 plus BC minus C plus AB minus A and minus AC. Then similarly for treatment C we get for main effect C we get factorial effect total square bracket capital C, and it is ABC plus C minus 1 plus BC minus B plus AC minus A minus AB. Then next effect totals are for interaction effect. For interaction effect AB, factorial effect total is denoted by square bracket AB, and it is ABC, that is ABC treatment total minus BC treatment total plus this AB minus B minus AC plus B minus A and plus 1. Then for treatment combination, for interaction effect AC, factorial effect total is denoted by square bracket capital AC, and it is ABC treatment total minus BC treatment total minus AB treatment total plus A plus AC minus C minus A plus 1. So to remember this formula, first understand what is the interaction effect AC. So interaction effect AC is 1 upon 4 A minus 1 B plus 1 into C minus 1. So simplify these brackets A minus 1 B plus 1 into C minus 1 and replace that treatment means by their treatment total. So we get this formula. Then for interaction effect BC, factorial effect total is denoted by square bracket BC, and it is ABC plus BC minus AB minus C minus AC minus C plus A and plus 1. Then factorial effect total for second order treatment interaction effect ABC is denoted by square bracket ABC, and it is ABC plus A plus B plus C minus AB minus AC minus BC and minus 1. So to remember this formula, first understand formula for interaction effect ABC, and it is 1 by 4 A minus 1 into B minus 1 into C minus 1. So simplify these three brackets A minus 1 into B minus 1 into C minus 1 and replace that treatment means by their treatment total. So we get this formula. Then we will discuss sum of squares, formulas for sum of squares. So here total sum of square is denoted by SS capital T, and it is summation over I is running from 1 to 8, since we have 8 treatment combinations in 2Q factorial experiment, into summation J is running from 1 to R. So here R denotes number of replicates, so we repeat this experiment R number of times, into Xij minus X dot dot bar bracket square. So Xij is the observation due to ith treatment and jth block. Okay, since we use here randomized block design. Minus X dot dot bar is a grand mean bracket square. And to solve any example, we use that correction factor formula to find SST. Then second one is a sum of square due to block. It is denoted by SS small b, and it is summation I is running from 1 to 8, J is running from 1 to R, X dot J bar minus x dot dot bar bracket square. So here x dot j bar is jth block mean. So with the help of this formula, we find sum of square due to block. Then next is sum of square for factor A. It is denoted by SS, the base capital A, and it is a factorial effect, for factor A square upon 8 into R. So here we have already discussed expression for this. Okay, our formula to find this factorial effect total for factor A divided by 8 into R. Since 8 is number of treatments and R is the number of replicates. Then sum of square due to factor B or main effect B is SS capital B, and it is square bracket B square upon 8R. Then third is sum of square for main effect C. It is SS capital C to the base capital C, and it is square bracket C square upon 8 into R. Then next sum of square is for interaction effect. So it is denoted by SS to the base capital AB, and it is sum of square due to interaction effect AB, and it is factorial effect total for AB bracket square upon 8 into R. Then next sum of square is SS the base AC, that is sum of square for interaction effect AC, and it is factorial effect total for AC square upon 8 into R. Then next is sum of square due to interaction effect BC. It is denoted by SS to the base capital BC, and it is BC square upon 8 into R. Then sum of square for second order interaction effect ABC is denoted by SS to the base capital ABC, and it is factorial effect total for ABC square upon 8 into R. Now here we have total sum of square, block sum of square, and sum of squares for main effect and interaction effect. So with the help of this, we can find sum of square due to error, and it is found with the help of this formula SST minus SSB minus SSA, SSB minus SSC minus SSAB minus sum of square due to AC, sum of square due to BC minus sum of square due to ABC. So use this formula to find sum of square due to error when we solve any example based on this 2q factorial experiment. Now we will discuss ANOVA table for this 2q factorial experiment when we arrange this experiment in randomized block design. So this is our ANOVA table. In this table we have sources of variation, degrees of freedom, sum of squares, mean sum of squares, and variance ratio to test given hypothesis. So first sources of variation is block effect. So for this we have degrees of freedom R minus 1. Sum of square is denoted by SSB. Mean sum of square is sum of square due to block upon its degrees of freedom R minus 1. Then we have main effects. So for main effect A, main effect B, and main effect C, its degrees of freedom is 1. Okay. So for main effect A, degrees of freedom is 1, and its sum of square is denoted by SSA. Mean sum of square is same as sum of square since its degrees of freedom is 1. For main effect B, degrees of freedom is 1. It is sum of square is denoted by SSB, and mean sum of square is nothing but sum of square due to main effect B. Similarly, for main effect C, degrees of freedom is 1. Sum of square is denoted by SSC, and mean sum of square is denoted by MSC, and it is same as sum of square due to main effect C. Then we have first order interaction effect AB. For this also we have degrees of freedom 1. Its sum of square is denoted by SSAB, and mean sum of square is denoted by MSAB, and it is same as SSAB. Then first order interaction effect AC has degrees of freedom 1. Its sum of square is SSAC, and mean sum of square is MSAC, and it is SSAC upon 1. Then interaction effect BC has degrees of freedom 1. Sum of square is denoted by SSBC, and mean sum of square is denoted by MSBC, and it is same as SSBC. Then second order interaction effect is ABC. For this also degrees of freedom is 1, and sum of square due to ABC is denoted by SSABC, means sum of square is also sum of square. It is denoted by MSABC. Then error degrees of freedom. Okay, so here we know that in RBD error degrees of freedom is T minus 1 into B minus 1, where T is the number of treatments and B is the number of blocks. So in this 2Q factorial experiment, we have 8 treatment combinations. So our error degrees of freedom is T minus 1 into R minus 1, since here we have R number of blocks. So 8 minus 1 is 7. So for error degrees of freedom is 7 into R minus 1. Sum of square is denoted by SSE, and mean sum of square is denoted by MSE. And it is sum of square due to error upon its degrees of freedom 7 into R minus 1. Then for total, we know that in RBD degrees of freedom is TB minus 1. So in this 2Q factorial experiment, T is 8. So here we get 8R minus 1 degrees of freedom for total. And total sum of square is denoted by SST. So with the help of this mean sum of squares, we find variance ratio to test above 8 hypotheses. So for block effect, it is denoted by capital F to the base B, and it is MSB upon MSE. That is mean sum of square due to block effect upon mean sum of square due to error. Then for main effect A, it is denoted by capital F to the base capital A, and it is MSA upon MSE. Then for main effect B, it is denoted by capital F to the base capital B, and it is MSB upon MSE. For main effect C, it is F to the base capital C, and it is MSC divided by MSE. For interaction effect AB, it is capital F to the base AB and MSAB upon MSE. For AC interaction effect, it is capital F AC, and it is defined as MSAC upon MSE. For interaction effect BC, it is FBC, MSBC upon MSE. And for second order interaction effect, variance ratio F is denoted by capital F to the base capital ABC, and it is MSABC upon MSE. So with the help of this F ratio, we make conclusion for our hypothesis. So these are the conclusions for our hypothesis. So if this FB is greater than critical value, then we reject our first hypothesis at given alpha percent level of significance, that is there is significant difference between block effects. So in this block effect, our critical value is F with block degrees of freedom R minus 1 and error degrees of freedom 7 into R minus 1 with alpha percent level of significance. Then if this FA is greater than critical value, then we reject our second hypothesis that H0A at given alpha percent level of significance, that is there is a significant difference or main effect A is significant. And in this case our critical value is F with 1 degrees of freedom, that is main effect degrees of freedom comma error degrees of freedom comma alpha percent level of significance. Then if this FB is greater than this critical value, then we reject our H0B at given alpha percent level of significance, that is main effect B is significant. Then if this FAB is greater than critical value, then we reject our H0AB at given alpha percent level of significance. Then if this FC is greater than critical value, then we reject H0C at given alpha percent level of significance. Then next conclusion is for interaction effect AC. So if this FAC is greater than critical value, then we reject our hypothesis H0AC at given alpha percent level of significance, that is interaction effect AC is significant. Then if this FBC is greater than critical value, then we reject our hypothesis H0BC at given alpha percent level of significance, that is interaction effect BC is significant. Then if this FABC is greater than critical value, then we reject our H0 ABC at given alpha percent level of significance. It means that if we reject our hypothesis, then main effect ABC or second order interaction effect ABC is significant with their levels. So this is about statistical analysis of 2Q factorial experiment when we arrange this experiment in randomized block design. Thank you.